Robot goes rogue at school sports day. Dancing humanoid malfunctions in front of shocked students. A dramatic moment at a school sports day in China has gone viral after a humanoid robot suddenly malfunctioned during a live performance, forcing handlers to rush in and remove it from the field before anyone was hurt. Now let's explore this story in detail and uncover the facts on our AI podcast.
I want you to picture a scene playing out on a really lively school sports field.
Okay, set the stage for us.
So you're standing on the sidelines in the Xinjiang Uyghur Autonomous Region in northwestern China. The weather's clear, the energy from the crowd is super high, and the kids are incredibly excited for the day's events.
Right, sounds like a normal sports day.
Exactly, except taking center stage on the turf isn't a student, but a full-size humanoid robot.
Oh, wow.
Yeah, and it's performing these highly choreographed, really energetic martial arts kicks to entertain the crowd.
Yeah.
And, for a few minutes, it is this flawless, mesmerizing demonstration of modern engineering
Right, until it isn't.
until it loses its footing. It crashes hard onto the turf.
Yeah.
But instead of, triggering a safety mechanism and just powering down, it begins violently jerking around.
Yeah, that video is intense.
It's wild. It starts throwing these unpredictable, high-velocity kung fu kicks from the ground while all the children are scattering to get out of the way.
I mean, it completely shatters that illusion of technological control, right? And in a very public, very physical manner.
Totally.
Because when we see a humanoid machine executing perfect martial arts forms, we project a level of intelligence onto it that, well, simply does not exist.
We just assume it knows what it's doing.
Exactly. We assume it understands its environment. But the moment it falls and begins flailing near running children, the mask slips. You're suddenly looking at a heavy industrial machine trapped in a chaotic algorithmic loop.
And that collision between, controlled technology and chaotic reality is our mission for this deep dive.
It's a really critical topic right now.
It is. We are unpacking the reality behind this viral school incident, looking at the mechanical failures at play, and exploring the much broader, really urgent implications of dropping unpredictable bipedal technology into our everyday public spaces.
Yeah, we have to move past the novelty of these viral videos.
Right. We need to understand the physics, the psychology, and frankly, the regulatory nightmare of integrating heavy robotics into our schools, our shopping malls, and public events.
Because that transition from the laboratory to the public square, it's happening much faster than most people realize.
Oh, definitely.
We are looking at a near future where the spaces you inhabit daily are going to be shared with autonomous machines. So understanding where the friction points are right now gives us a crucial preview of the challenges ahead.
So let's break down the mechanics of this Xinjiang incident from the beginning. At this sports day celebration, the bipedal robot starts out functioning perfectly.
Right, it's doing great at first.
It's executing these sweeping martial arts style moves to a stunned audience of students and staff. And I mean, in a vacuum, this is an incredible feat of balance and motor control.
Oh, absolutely. Just standing upright and moving is a massive engineering hurdle.
Why is it so hard?
Well, a humanoid robot is constantly solving what roboticists call the inverted pendulum problem.
The inverted pendulum.
Yeah, think of it like balancing a broomstick on your finger. It has a really high center of mass positioned over a very small base of support, its feet.
Oh, right. That makes sense.
So to keep from tipping over, its internal gyroscopes, accelerometers, and force sensors are making hundreds of micro-calculations every single second.
Wow. Every second.
Every second. They are constantly sending signals to the actuators in the ankles, the knees, the hips, just to maintain equilibrium. And during that initial dance, the environment is static.
All right. It's just doing its thing.
Exactly. The robot is just executing a closed loop of pre-programmed movements.
But then the environment completely shifts, right? Because the script calls for the students to run onto the field for a synchronized routine.
Right. The variables change.
Yeah, as the dynamic changes, as the kids enter the frame and the turf gets crowded, the machine loses its balance, it trips, and it hits the ground.
And when a complex machine like that loses its center of gravity, the physical impact completely overwhelms its internal systems.
It just freaks out.
Basically, yeah. The sensors are suddenly flooded with chaotic data, the horizon line pitches violently, and the ground impact just spikes the force sensors.
See, my immediate thought when watching something like this is, why doesn't it just stop?
It seems like the obvious solution.
Right. I mean, if my robotic vacuum gets wedged under the couch, it beeps twice, it shuts down the motors,
Yeah.
and it waits for me to rescue it. That is a basic fail-safe.
Right.
But this humanoid robot weighs as much as an adult. It's built out of metal, and it is surrounded by kids.
Yeah.
Yet, instead of deploying a calm shutdown sequence, it starts kicking its legs in entirely unpredictable directions.
Well, you have to remember, a robotic vacuum operates in a flat, two-dimensional plane.
Okay.
Its failure state is incredibly simple, just stop the wheels. But a bipedal robot is fighting gravity in 3 dimensions.
I see.
Its primary software directive, deeply embedded in its code, is to maintain balance and avoid falling.
So it's basically programmed to never fall down.
Right. So when it hits the turf, that programming doesn't just magically tone off. The software registers a catastrophic loss of equilibrium, and it starts firing the motors at maximum torque to correct a fall that, well, has already happened.
Wait, really? It's trying to stand up while it's on the ground?
Exactly. It isn't trying to do martial arts on the turf. It is trapped in a mechanical panic attack. It's rapidly overcompensating based on just garbage data from its disoriented sensors.
So it is essentially fighting the fall, totally unaware that by fighting it, it's turning its own whims into high-speed blunt force weapons.
That's a perfect way to put it, yeah.
I mean, the performers had to quickly back away.
Yeah.
Within seconds, a handler actually had to sprint onto the field, physically tackle the flailing machine, and carry it away.
Which is terrifying when you think about it.
Nobody was hurt, which is incredibly fortunate. But, I mean, the reliance on a human handler sprinting to scoop up a malfunctioning machine, that feels like a glaring failure of internal safety protocols.
It absolutely is. It demonstrates that the software prioritized mechanical recovery over environmental safety.
Explain that a bit more.
Well, in a controlled laboratory setting, you want the multi-million-dollar robot to try and save itself, right? To prevent damage to its chassis.
Well, sure, you don't want it breaking.
But on a school sports field, the absolute priority must be going limp to protect bystanders. The failure to distinguish between those two environments is a profound oversight by the engineers.
And it's funny, well, not funny, but the reaction on the Chinese social media platform, GN, was this weird mix of shock and humor.
Yeah, I saw some of those comments.
One user joked that the robot was just, quote, confused by too many people and just wanted to dance without causing harm.
Right, assigning human emotions to it.
Exactly. And while it's easy to laugh at a viral video of a confused robot, it completely sidesteps the real danger here. We are treating highly complex industrial-grade equipment as a novelty toy. I mean, think about it. If this was a heavy, motorized robotic arm from a car manufacturing plant, it would be bolted to the floor behind reinforced glass or a steel cage.
100%.
We would never allow it on a field with children.
Yep.
So why are we giving this machine a free pass just because it is shaped like a human?
Because that humanoid form factor masks the industrial reality of the machine.
It tricks us.
It does. The aggressive deployment of these robots into everyday public spaces, which, by the way, is currently a major national initiative in China, is explicitly designed to normalize artificial intelligence.
So they want people to get used to it.
Exactly. By putting them in schools, exhibitions, and entertainment shows, the goal is to make advanced AI tangible and approachable.
Right.
You build public trust by wrapping really complex mechanics in a familiar, human-like shell.
But that normalization completely ignores the physics. We are scaling up from controlled, sterile labs where every single variable is known, to hundreds of public schools where kids run in unpredictable patterns. The ground is uneven, the weather changes.
It's chaos.
It is. We are dropping heavy metal, high-voltage batteries, and powerful motors into the most chaotic environments possible.
And when you do that, you are mathematically guaranteed to encounter edge cases.
Edge cases being
Situations the programmers simply never anticipated. A sudden influx of running kids alters the robot's spatial mapping.
Oh, right.
Where the lighting changes, which confuses its optical sensors. The transition from the lab to a public space introduces a volume of variables that current algorithms just cannot account for with absolute certainty.
And that blind spot in the technology is already causing real-world harm.
It's not just theory anymore.
No, the Xinjiang Sports Day fall is not an isolated event. There's a documented emergent pattern of incidents where the interaction between humanoid robots and the public totally breaks down.
Yeah, the rush to integrate these machines for the sake of public spectacle has led to some really notable failures in safety management.
Like earlier this year, there was a live dance show in Shaanxi province.
Right, I remember reading about this one.
A robot was performing this spinning routine on a stage. but it swung its arm too close to the edge of the platform and actually struck a young boy in the face.
Which is horrifying. And it's a textbook example of the danger of pre-programmed kinematic motion in a dynamic space.
Because it didn't know the boy was there.
Right. The robot in Shaanxi was likely just executing a precise sequence of coordinates. It was told to move its arm from point A to point B at a specific velocity.
It was just following instructions.
Exactly. It did not see the boy in the way a human would. It had absolutely no contextual awareness that a biological organism had entered its physical strike zone. It simply executed its code.
See, we assume it knows not to hit the kid in the face, because a human dancer would instantly recognize the danger and stop.
Yes.
We project our own spatial awareness onto the machine.
We do, because we are biologically hardwired to anthropomorphize.
Right, putting human traits on non-human things.
Exactly. When we see 2 arms, 2 legs, and a face, our brains subconsciously assign human traits to that object. We expect it to possess empathy, restraint, and an understanding of consequence.
But it's just code.
Right. The face on a humanoid robot is merely a user interface. It is a plastic or digital facade designed to make you feel comfortable. It has absolutely no correlation to the cognitive awareness of the underlying code.
And the psychological impact of that mismatch can be intense.
Is deeply unsettling.
There was another incident involving a humanoid robot behaving so unpredictably that it absolutely terrified an elderly woman.
Yeah.
The situation escalated to the point where the police were called to intervene.
Imagine that 911 call.
I know. The idea of law enforcement responding because a citizen is terrified of a machine walking down the street, it feels like a scene from a dystopian novel.
It really does. But it highlights a phenomenon known as the uncanny valley.
Where it looks almost human, but not quite.
Exactly. It looks almost human, but its unnatural movements or its lack of responsiveness trigger a profound distress response in our brains.
So it's not just the physical danger.
No. The psychological friction of sharing public space with autonomous machines is going to be just as challenging as the physical risks. When a machine violates our social expectations, like when it moves erratically or fails to recognize personal space, it creates genuine public panic.
So if these are the teething problems we are seeing in the early stages of deployment, the implications for the near future are just staggering.
They are.
We have to consider what happens when the market explodes and these robots move from being occasional novelties to ubiquitous presences in our cities.
And that's exactly what robotics experts Carl Strathern and Emilia Soboleska have been warning about.
Right. They are from Edinburgh Napier University, right?
Yes. They've been analyzing these deployment patterns, and their assessment of the current landscape is a pretty stark warning regarding the next decade of automation.
Because they are looking at the surging sales projections and incidents like the ones in Xinjiang and Shaanxi, and their conclusion is that governments are completely unprepared.
Completely in the dark.
The guardrails simply do not exist. They predict that without immediate, intense oversight and stronger safety rules, the public is going to face a significant increase in accidents in shopping malls, schools, and civic centers.
The core of their argument is this massive widening gap between commercial ambition and legislative capability.
The laws can't keep up.
Not even close. The robotics industry is moving at breakneck speed. Companies want to scale up, demonstrate capabilities, and secure market dominance. But the technology is iterating much, much faster than the safety laws designed to contain it.
I mean, how does a government even begin to regulate a humanoid robot?
It's a huge challenge.
Because if a company builds a new car, it has to pass physical crash tests, weight restrictions, emission standards.
Yeah.
And if a company builds an app, it falls under data privacy and software regulations. But a bipedal robot is a heavy physical vehicle that is driven by complex software.
It is both a hardware hazard and a cognitive hazard at the same time. The physical chassis can crush you, and the software dictates the behavior that leads to the crush.
So do you mandate how the AI processes its spatial mapping?
And that right there is the regulatory nightmare.
Right.
Because our entire consumer safety framework is built on static products. Think about testing a lawnmower or a toaster.
Okay, a toaster.
The regulatory body tests the device once. If the blade on the lawnmower stops when you let go of the handle, it passes inspection and goes on the shelf.
And it never changes.
Exactly. 5 years later, that lawnmower still functions exactly the same way. It is a static machine.
But a humanoid robot running on advanced neural networks is fundamentally different.
It is a dynamic product. It is constantly collecting environmental data, refining its algorithms, and most importantly, it's receiving over-the-air software updates from the manufacturer.
Oh, wow.
Yeah.
Meaning the machine that passes a safety inspection on a Tuesday might download an entirely new behavioral algorithm by Thursday.
Precisely.
The parameters of how it moves, how it reacts to a fall, or how it identifies a human could change overnight.
Making traditional certification frameworks virtually obsolete.
That's terrifying.
It is. Because by the time a regulatory body drafts a comprehensive law about, say, maximum weight limits or motor torque in public spaces,
The tech has already moved on.
right, the industry has already moved on to deploying complex predictive AI that the law doesn't even address.
So what happens in the meantime?
Until the oversight catches up to the commercial ambition, the public space effectively becomes the beta testing ground for experimental robotics.
Man. We started this deep dive looking at a single moment of mechanical failure on a school sports field.
A very dramatic moment.
Very. A humanoid robot crashing to the turf, trapped in an algorithmic loop, throwing kung fu kicks while kids scattered, and a handler desperately tried to shut it down.
Yeah.
But we moved past the spectacle of that viral video to really understand the physics of bipedal balance and the dangers of the inverted pendulum problem when those sensors fail.
And we trace the broader pattern of how the rush to normalize AI in public spaces is actually leading to physical harm.
Right, looking at the child struck in Shaanxi province.
And the profound psychological distress caused when machines trigger our anthropomorphic blind spots.
We examine the illusion of safety created by the humanoid form and why our brains falsely trust a plastic face that's hiding heavy industrial equipment.
Which is a hard habit to break.
It is. And finally, we looked closely at the warnings from researchers at Edinburgh Napier University. The gap between static safety laws and dynamic, over-the-air updated AI is creating a regulatory void, just as sales are projected to surge.
The friction points we are witnessing today are really just the very early tremors of a massive shift in how we interact with our built environment.
Because these machines are leaving the laboratory and they're walking onto our sidewalks. They're being actively designed to share space with you in your local shopping mall, at your community events, and in your kids' schools over the next 10 years.
You're going to be everywhere.
So I want to leave you with a final thought to consider as you go about your day. Think back to that chaotic scene on the turf in northwestern China.
A sports day.
Yeah. When a 150-pound experimental machine is invited to perform alongside children, and it suddenly loses its balance, who is ultimately responsible when things go wrong?
That is the million-dollar question.
Is it the handler on the sidelines who couldn't tackle the heavy machine fast enough? Is it the software engineer thousands of miles away whose code failed to initiate a safe shutdown? Or is it the school administration that invited industrial equipment onto a field with running children in the first place?
It's a complicated web of liability.
It really is. And as these robots become an everyday reality, the question of liability is one we will have to answer long before the next machine takes a fall.
Okay, one question for you. Could humanoid robots truly be trusted to perform safely around children in schools after this shocking sports day malfunction? Or does this incident prove that technology is still too dangerous for public events? Don't forget to comment it. Thanks.